In this session for the 8th standard CBSE Mathematics, we are going to discuss the topic direct and inverse proportions and their applications to practical problems. Direct proportion is whenever a quantity increases and the related quantity also increases, or whenever a quantity decreases, the related quantity also decreases. That's all. This is called direct proportion. In inverse proportion, is the other way about. When a quantity increases, the other related quantity decreases. Or if the quantity decreases, the related quantity will increase. Just the opposite. Now we are going to see this. What are direct proportions? First, let us see what is direct proportion. Money and food. More the money you have, the more the food you can buy, or any commodity for that example. Wages and efforts. Efforts you put, the more work you do, the put your efforts, you get more wages. Storage quantity and space. Storage quantity means the amount of space you have in the room. You can store more space, more number of articles. Storage space and the quantity of materials you can store in that space. More the speed of a vehicle, the more the distance traveled in a given time. In a particular time, you can travel more distance if your speed is more. This is direct proportion. So we consider this direct proportion like this. We say x and y are in direct proportion if x by y is equal to a constant k. K is a constant. So the ratio x to y, x by y, will always be a constant if they are in direct proportion. X and y are related by the relation x is equal to ky. We also have in physics, we have force is directly proportional to the acceleration. Then we say F is equal to ma. M is a mass, which is a constant. So similar to that, we have a relationship like this between two quantities. The consumption of petrol and the distance traveled by a car is a case of direct proportion. See, the more the fuel you fill, you can travel more distance in the by the car. The same quantity and the quantity of petrol. If the quantity of petrol is more, you can travel more distance. You can cover more distance. Similarly, the total amount spent and the number of articles purchased is also an example of direct proportion. The amount spent, the money you have, you can, if you have more amount, you can spend, you can buy more number of articles. This is an example of direct proportion. Now let us see the applications of direct proportion to practical situations. In example 2 of your NCERT textbook, you can refer to that. An electric pole 14 meters high casts a shadow of 10 meters. Find the height of a tree that casts a shadow of 15 meters under similar conditions. Here, similar conditions means that the light source, namely the sun, at a particular time doesn't change. The position of the sun or the position of the light source doesn't change. That means it is at a particular time. The electric pole casts a shadow, which is 14 meters high, casts a shadow of 10 meters. What will be the height of the tree that will cast a shadow of, at the same time, it casts a shadow of 15 meters? That is what the question is. Try to understand the question. Now, there are two quantities here, two variables. One is the height of the object. The other one is the length of the shadow. So we form a table. We need to find the height of the tree. So let us assume the height of the tree to be x meters. We form a table as shown below. Height of the object, we tabulate. First, we put the known quantity. The height of the pole we know, so 14. The second column, the same row, second column, we have the x here, the height of the tree, which is to be found out. Length of the shadow in meters is the variable, the second variable. And we know the length of the shadow of the pole. So we write it here. And we also know the length of the shadow of the tree, which is 15 meters. And it's also can be written here. So we have to find the height of the tree. which is the variable x. Note that more the height of an object, the more would be the length of the shadow at the same time. Now we have the relation x by y is a constant, or x1 by y1 is equal to x2 by y2. This is a very simple relationship, which is proportional. That means they are proportional. They are in direct proportion. Now consider this tree. We take the variable x to denote the height of the object and the variable y to denote the length of the shadow. From the table, we get x1 equal to 14 meters and x2 is equal to x, the height of the tree. y1 is equal to 10 meters and y2 is equal to 15 meters, which is, these are the lengths of the shadows of the pole and tree respectively. 10 being the length of the shadow of the pole and 15 meters is the length of the shadow of the tree. These are given in the question itself. Now consider the figure below depicts a tree and a pole casting shadows on the ground. Let us see this. This figure shows you how the shadow is, they are perpendicular here, the vertical lines. The pole is also at the same time, it is casting a shadow. Now we will have 14 by 10, which is nothing but 14 by 10 is equal to x by 15. This is what we get. 14 by 10 means 14, the ratio of the shadows is equal to ratio of the heights. The height of the tree is not given, the height of the pole is there. So we write it this way. See, ratio of the y, x1 by y1. So the corresponding shadow, x1 by this corresponding shadow of the tree is 15. The height of the pole is 14 meters and the corresponding shadow will be 10 meters. It is given the question. You just refer to the question. 14 meters height of the pole and which is casting a shadow of 10 meters here. So the denominators represent the length of the shadows, corresponding shadows. Okay. Here, the denominator, numerator by denominator. X by 15, x1 by y1, x1 by y1 here, x2 by y2 here. These are ratios are being compared here. Equal, both are equal. So when cross multiplying this, while solving for x, we can say we can multiplying both sides by 15. And solving for x, we get the value of x as 21 meters. It's quite easy. 21 meters is the height of the tree. There is the one way to solve this problem. Alternately, we can also write this way. We can write the ratio of the heights is equal to the ratio of the shadows, length of the shadows. This is another way of, whichever is easier, we can just follow. This is also going to be the same. 14 by x. 14 is the height of the pole and x is the height of the tree. Ratio of the heights is equal to length of the shadows 10 by 15. 10 meters by 15 meters. Again, solving for x, we get the same answer, 21 meters, the height of the tree. Therefore, we have concluded that this is one example of direct proportion. There are other examples in the textbook. You can go through them. We will also, in one more session, we will also allot one session for the doubt clearing session, where some questions from the exercises can be solved. Now we see inverse proportions. What is inverse proportions? The concept of inverse proportion. Freshness of vegetables and time. The freshness is more when the time is less. As the time increases, the vegetables start becoming less fresh. It decreases. The freshness of the vegetable decreases. So one increases, the time increases, the freshness decreases. Expenses and savings. As the expenses increase, the savings will reduce. If for a given income, of course, one particular income you have, you spend more means your savings will get reduced, isn't it? So that is how you have to think of. So we buy more things, we spend more money, the expenses increase, but your savings will get reduced for a particular income. Toys. and free space in a room, as the toys are dumped in a room, or more articles are dumped in a room, your free space will get reduced. More the number of articles in the room, the less amount of free space in the room. The one quantity is increasing, the other quantity is decreasing. Also, one more example is there. When number of persons increase, the food consumption, the number of persons, each person will get less amount. That is, it is an example. We'll see in that example question. Okay, carry on. We'll go to the example of one example for inverse proportion. The price of one book and the number of books bought. See, it's very obvious that if the price of the book, one book is more, the number of books for a given amount you have, you can buy less number of books. So more the price of one book, the less number of books you can buy. It applies to any article, price of each. So thus, when there are two quantities, X and Y, vary in inverse proportion, then there exists a relationship of the type xy equal to k. The product of the two variables is equal to constant. This is the relation between inverse. For inverse xy equal to k, or k being a constant, y1 and y2 are the values of y corresponding to the values x1 and x2 of another quantity x respectively. Then x1 y1 is equal to x2 y2, which is equal to constant k, or x1 by x2 is equal to y2 by y1. That is the difference between the direct variation and inverse proportion. In direct proportion, it was the same, but here it is just the opposite. So x1 by x2 is equal to y2 by y1. That's all. We can vary this, we can represent this concept of inverse proportion as direct proportion is x is proportional to y, whereas inversely proportional is x is proportional to 1 by y. That is the difference. Reciprocal, 1 by y. The other quantity, when one quantity increases, the other quantity will decrease in the case of inverse proportion. Okay, next what we do is, we take up an example of inverse proportion. In this inverse proportion, we have, in this example, 7. You can refer to the example 7 of your NCERT textbook. 6 pipes are required to fill a tank in 1 hour 20 minutes. How long will it take if only 5 pipes of the same type are used, same size? See, if 10 pipes are used, 6 pipes are used, 6 pipes are used to fill a tank in 1 hour. Only 5 pipes are used, then it will take more time, definitely. The number of pipes reduced, the quantity of water also will be less, and it will take more time to fill the tank. That's all. That is the inverse proportion. So we form a table again. Here, the following table, let the desired time to fill the tank be x minutes with only 5 pipes. So number of pipes, we'll put it in as a variable, say some variable. And the time taken, we will take it as x here. So we have the variables 80 and x. 80 is the time taken for 80. How did we get that 80 done? Can you think of it? 1 hour and 20 minutes. You know that 1 hour is 60 minutes. 60 plus 20, 80. That's it. That is why you get 80 minutes here. We convert everything to minutes. So if we have it in a fraction, it will be difficult to handle. So we convert everything to minutes. All quantities to a common unit. That is, 1 hour is taken as 60 minutes and 20 minutes. So we add that 20 minutes to that 60 minutes to get 80 minutes. So 6 pipes, 80 minutes, 5 pipes, how much time? That's all. So it's just the multiplication of the two quantities and equate them. So very simple this. You have to simply multiply 60 and 80, equate it to 5 into x. 5x is equal to 80 into 6. Therefore, x is equal to 80 into 6 by 5. We cancel that 5 with the 80 as 16 and get the answer as x is equal to 96, which means 96 minutes, or we can convert this back to hours and minutes, means 60 minutes is 1 hour. The remaining 36 minutes is minutes. 60 plus, we can write this as 60 plus 36, isn't it? So 60 is 1 hour. So 1 hour, 36 minutes. And that's the answer. Time taken to fill the tank if only 5 pipes are of the same type are used. So we see that the time has increased by 16 minutes. See how many minutes it has increased? 1 hour, 20 minutes, 6 pipes. But 5 pipes, only 5 pipes means it will take more time. The number of pipes is decreased, but it takes more time. 1 hour, 36 minutes. Okay. Now take another example of inverse proportion where food consumption and the number of students. It will last for more days or less days. That is what, if the more number of students are there in a hostel, the same food is available if there, it will last for less number of days because the number of students have increased. So here there are 100 students. There is provision only for 20 days. If there are 25 more students join the group, so what happens to that? There will be 125 students, 125 students. Again, we form the table, number of students. Here the variables are number of students and number of days. That's all. You have to identify which are the two variables. The variables are 100 students, the number of students, and the number of days. It will last. The food will last. Now, the food provision lasted for 20 days. So 100 students, it lasted for 20 days. So 125 days, how much time? Y. Let us take it as Y. Now we just multiply these two. First column, number of students into number of days. 100 into 20 is equal to, again, number of students into number of Y. 100Y, 125Y. So 125Y, 125, 125 into Y is equal to 100 into 20. Thereby, we solve for Y is equal to 100 into 20 divided by 125, which is equal to 16. Y is equal to 16. So the provision will last for only 16 days if 25 more students joined. Alternately, you can do it by proportion method, ratio method also, by product of the means, product of the extremes, and so on. That's another method, but this method is quite simple. You can follow any one method if you want. You can just go through and find out which method is suitable. And see that you have this inverse proportion is very simple. You just have to multiply this way and equate these two. XY is a constant, that's all. One variable is X, the other variable is Y. So X1, Y1 is equal to X2, Y2, and thereby equate the two, that's all. Thereby you get 16. Y is equal to 16. 16 is the number of days the food will last if 25 more students join the hostel. Okay. Now you will be able to solve a few problems from the exercises 11.1 and 11.2 of the NCERT textbook. In the next session, we will see a few problems there. We'll see our doubts in one more session. We'll have one more session on this direct and inverse variations, inverse proportions. To conclude this session, here is a summary. The quantity 1 and quantity 2 both are arrow up. It's very easy to remember this. Both increase means direct proportion. One increases, the other one decreases, or one decreases, the other one increases. Then it's called inverse proportion. This is the summary. You remember this. This concept is important. You can apply it to any problem. You try to solve a few questions in exercise 11.1 and 11.2. Exercise 11.1 is based on direct proportion. And exercise 11.2 is based on inverse proportion. Okay, that's it. So this is what we saw. In this session, we saw direct and inverse proportions. Direct and inverse proportion and their applications to practical situations, practical problems. Thank you and Best wishes from Beta Online Learning.